everyone, my name is Gabby with Arizona Science Center. Thank you so much for joining us for our final day of our virtual Snow Week experiences. All week long we've been chatting with snow pros at Arizona Snow Bowl to learn about the awesome science and engineering careers that are in snow science. Because those are so out of this world, we're going to do another one today that's going to investigate science in outer space. So we're going to talk a little bit about something called material science. Have you ever heard of material science? What do you think a material scientist works with? Well, the easy answer is materials. They test materials and see what they work for, what they don't, what problems they may have, and they make new materials as well. Why might this be important to space exploration? Well, there's a lot going on in outer space, whether it's the pressure, the temperature, the weightlessness. All of these different factors come into play when we're sending people to space or different technology and devices. So we're going to investigate what happens when materials interact with extreme cold, a condition that might happen, and NASA actually does similar research to this. So we're going to use something called liquid nitrogen. Now, liquid nitrogen is really, really cold, negative 321 degrees. That's colder than anywhere here on Earth. On Neptune's moon Triton, they actually have giant geysers of liquid nitrogen. So we're going to take a look at one of those right now just to see how the liquid nitrogen acts different from other liquids that we might know, maybe water or juice. What do you notice as soon as we start taking this out? Well, I see some sort of smoke or steam coming off, and it's jumping in the ladle. That's because liquid nitrogen is actually boiling at room temperature. So similar to your tea kettle that you might have at home. It acts similar to water, but it looks a little different. We're gonna go ahead and we're gonna plug it in and see a mini liquid nitrogen geyser. Are you ready? 3, 2, 1. Wow. So you can see that liquid nitrogen, it's heating up, it's expanding in our atmosphere, and this might change the way that materials act. So let's investigate with different materials to see how it might change plastics or metals or woods. So first, we're gonna do this one first because it has to sit for a little bit. I have a metal ball and hoop. Now right now, the hoop goes through the ball very, very easily. But what would happen if we take our hoop and give it a dive in liquid nitrogen? Well, let's investigate. That's taking a dive in there, so I want you guys to make a hypothesis. Do you think it's gonna change at all? We'll find out. Now, let's see what happens when we put things in liquid nitrogen that might have some sort of impact. So first off, I have this plastic water bottle. No more water in it, but what's inside? Some may say nothing, some say air, right? So there's air molecules inside of our water bottle. When we add this into cold, what do you think is going to happen? Let's find out. I hear something happening right away. Let's see, ready? Our water bottle has completely collapsed. So the cold air, or the cold liquid nitrogen, makes that air cold and condensed, and those molecules are getting closer together. Now something's happening as it's warming up. The bottle is expanding again. Those molecules are warmer out here. They can expand and spread apart. So this kind of impacted the plastic as well as the air inside of it. So we're seeing some different changes with materials here. Let's do something similar with a balloon here. Now this is a long balloon, doesn't quite look like it'll fit inside of our dewar with liquid nitrogen, but this is also filled with air. What's your hypothesis as to what will happen when we add this to liquid nitrogen? Let's find out. So we're gonna add this in. Ooh, I already see something happening at the top. All right, let's see. Our balloon has completely changed. It's almost like it's deflated, but as we watch it, as it warms up, it appears that it's growing again. Why might this be? What did we learn from our water bottle before? Well, the cold, negative 321 degrees to be exact, makes molecules get closer and closer together. And then when it warms back up, they can expand again. Now this acted a little different from our bottle because this is a different kind of plastic polymer. So plastics seem to act pretty strange in extreme cold. This is something that scientists might need to look out for. Now, we put some things in liquid nitrogen. Let's see what happens when we put liquid nitrogen in something else. We're gonna add some to this little beaker here, a small scoop of liquid nitrogen. Now, we saw what happened when we did it to the geyser, but in order to really see how those molecules are moving around, let's add a balloon to the top. Okay. Check it out. So our balloon is inflating. Those molecules, they're spreading out, they're expanding as they're warming up. So we're definitely seeing some changes here. All right, I'm gonna take this off. I don't want the balloon to pop too much. There we go. So an interesting investigation in learning how all these different things change. Now, let's see how our ball and our hoop are doing. I'm gonna go ahead and take our hoop out of the liquid nitrogen, and let's see if we can get the ball through it now. It's a lot more hard this time. It's a little more challenging. Oh, there we got it. Oh no, now it's done. So learning from what we did with our other experiments, what do you think happened to the hoop here? This is metal, this is different from our plastic polymers, but it acted in a similar way when exposed to really, really cold environments. Those molecules got closer and closer together, almost kind of changing the shape, very, very small amounts, kind of making our ball a little trickier to go back through the hoop. Oh, all right, I'm gonna set that off to the side. Now for our final experiment, we're gonna take a plastic ball here. So it's pretty squishy. It's hard, it's solid, but it's flexible. Notice the sound it makes on the table. Now I've had one sitting in the liquid nitrogen. Let's see what happens when we take this out of the liquid nitrogen now. All right, so we gotta fish this out. It's already making an interesting noise, a little different than our other one. That sounds a lot different on the table. Now to test the hardness of the ball, see how it changed it all, we're gonna go ahead and do a little break test. Ready? 3, 2, 1. That ball shattered like glass. Let's compare it to the non-frozen one. Completely different reactions. Take a look at this now. It's almost like a hard piece of glass, and it's very, very brittle. Now when this warms back up, it'll be just as flexible as our other ball, but the cold is changing the way that those materials are acting. So material science is a really, really cool way to investigate the world around us and see what new technology and engineering we can think of for the world outside of Earth. All right, thank you everyone so much for joining us for our virtual Snow Week this week. I had a lot of fun exploring different science careers with you all. Stay curious and keep imagining. See you all next time.